Alright, so this video is about graphing hyperbolas. We're going to do everything in this video. And so again, just a reminder, if x goes first, everything's about the x. So you can see that we are adding in the x coordinate and subtracting in the x coordinate. And if y goes first, we are adding and subtracting in the y coordinate. But you don't want to think about them as formulas other than the foci. It's mainly just logical as you move through it. So let's try one. What is our center here? So it's the same as before. It's always opposite for the x. Same as for the y. And so that's where we are centered at, -1, 2, right there. And then our a is always for the x, and our b is always for the 3. So now who came first? That would be x. So everything is about the x here, okay? For our vertices, our foci, everything is for x. So when we do this, we know we're going to go 5 units left and right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then up 3 and down 3, and then we make our little magical box. And we draw our asymptotes through the center and the corners, like that. So I like to go out, and then out, and that's where it is. And we know now that our graph is x. So since x goes first, we're going to graph in the x direction like that. And again, you can sketch if you're not smooth, and I'm not smooth. So look at that, see? Not smooth. And so we go out and then put our little arrows on it. So that's what our graph will look like. So where are our vertices? They're right here and right here. And so you can see that they are on the x-axis symmetry, right? If we moved it down, of course, but it's shifted. But in the x direction, that's how we open. So was 1, 2, 3, 4, 5. So all you're doing now is you're taking that 5 and you're adding it to the x. So we're going to go plus or minus 5 to it. And so our vertices now would be at -6, 2 and 4, 2. So we're going to take -1 and add 5. And we're going to take -1 and subtract 5 to the x. And that's your vertices. And then you just check it on your graph. So you can see that it's 4, 2. And then that one is -6, 2. So that checks perfectly. Equations of the asymptotes are amazing. All you're going to do is put y-2 and -1. This is another way of shifting with a line. So you can see we're now centered here. And for our box, all it is the slope is all we're missing. So we have our point of 1, 2. We just need our slope. So it's up 1, 2, 3, and then over 1, 2, 3, 4, 5. I wonder where I got those numbers. It's right here. Slope is always rise over run. And so since we're making a box here, you can actually see it in both formulas that it's the same. Equations of the asymptotes are the same because the box is the same. All that changes is if we're graphing up and down or left and right. So it will always be y minus k. So you just take that and place it here. X minus h here. And then b over a, because b is your rise. See, we're going to rise the b amount. And then a is the run, and you're going to run right here. So it will always be up b over a, and so your slope is going to be plus or minus b over a. Where am I getting plus or minus? Because you're also going to go down b over a for the other line. So this line right here has a negative slope, and this line right here has a positive slope. So plus or minus, and that's it. So it's b over a, and then y2 minus y1. All right, so all we have left now are our foci. So let's look and find our foci. So the formula for our foci is just like the ellipse, except we're going to put a plus now. So all we're going to do is add the square of both. And so that's 25 plus 9, which is 34. And then we plug that in our calculator to get an approximate, and you get 5.83. So what happens here is if you look at our graph, I'm going to do them in blue. If you count out 5.83, you get 1, 2, 3, 4. We're past. So remember our A was 5, and that's what we have here. So we're going to actually go a little bit past them each time. Your foci will be larger because you're adding, so they're outside each time. Let's look at Desmos. So you can see here is our graph, and there's our center, right? And there's our foci. So you can see from -1, that's our x value, they are 5.83 that way and 5.83 that way. So it's just like we did with the ellipse where we're going to add it to the x, except we don't care who's the bigger one in this situation. Right now it's about which one comes first. Whoever goes first, that's what we add everything to. But they will always be outside like that. So to get to the location of our foci, what we're going to do then, I'm going to move this over a bit, is you're going to take your vertex, or your center, sorry. Our center here is -1, 2. And again, you're going to add to the x. So we're going to put minus square root of 4 to go to the left, 34. And then we're going to take our center again, and we are going to add the square root of 34. And so that gives us -1 minus square root of 34, 2 for the location, and -1 plus the square root of 34, 2 for the other location. So that is how we find the location of our foci. So this one would be the -1 plus square root of 34, 2. And this one would be the -1 minus square root of 34, 2. And that's it. So that's everything that we have. Let's try one more. And of course, this one now is, everything is about y. Y comes first. So our b here would be 4 and our a is 3. We always want to keep our b with the y and our a with the 3. And of course, our center. And our center here is -1, 2. See, everything's backwards. So our x is -1, our y is 2, but everything will be about y. So we will be adding to the y coordinate here, to the 2. So we know we're going to get -1 for our vertice and everything else. That will not change. Okay, so let's graph what we have. So -1, 2. Our b is 4, so we will go up 4, down 4, right 3, left 3, and we draw the magical box and the asymptotes, and that's our positive asymptote. And that one is our negative. And we can give those equations very quickly now. So we know it's y minus 2, x plus 1, and 4 over 3. And I just noticed an error too. Up here it was x plus 1, so let's change that to a plus 1. So remember, asymptotes are always exactly the same because it's our shifting. We're basically shifting the line. That's our center of our line, and from there we go up b over a and down b over a. So we're doing the same thing here. Our center is -1, 2, and we are going up 4 over 3 and down 4 over 3 for both asymptotes. Okay, so vertices now. So vertices we're going to add to the y coordinate because it opens in the y. So we already know our graph will look like that. It goes up, and again, make sure these approach the asymptotes. So like that. Just rough sketch is fine, but again, showing approaching. I'm not looking for artists here. And so you can now see that our vertices are up 4, down 4 from the y coordinate. So we're going to add 4 and subtract 4. So -1, 2 minus 4, -1, 2 plus 4, and that would give us -1, -2, and that should check. See, right there, that's perfect. And then plus 2 would be -1 plus 6, and that is correct. And so those are your vertices, -1, -2, and -1, 6. So see, that's the same thing we did here, but on this one we added it to the x coordinate because the x came first. But this one is the y, so we add it to the y coordinate. Everything is on that axis here. That's why the x is not changing. -1, -1, -1. Everything's about y, so -1 gets ignored. All right, all we have left now is our foci. And so foci are the square root of our a squared plus b squared. And again, it doesn't matter the order. So this is 9 plus 16, which is 25, which is 5. So what we're going to do now is add that to our center, -1, 2, -1, 2. And again, it goes to the y because y is what we're doing here. So we're going to add the 5 and subtract the 5. So we get -1, -3. and negative 1 comma 7. And so let's plot those. So it's negative 1, and then we go up 5. So 1, 2, 3, 4, 5, and then down 5. 1, 2, 3, 4, 5. And so you can see that we are where we're supposed to be. That's at 7, and that's at negative 3. And so this one is negative 1 comma 7, and this one is negative 1 comma negative 3. All right, let's verify this in Desmos just to see how it looks. And so there we go. See? Everything checks out the way it's supposed to be. You can see that we add 5 this way, subtract 5 this way. Everything is graphed perfectly. Looks good. So that is our hyperbolas.